We will now see how the abstract factory design pattern can help us create instances of classes from the same set. First, we need to create an abstract factory. This will be a base class that will only define the interfaces for creating the products. This will create the instance of product A, and this will create instance of product B. And we'll use a forward declaration for both the classes. We don't need to include the header files. And let's not forget the virtual destructor. So these two methods are nothing but factory methods. So we can say that abstract factory is implemented through a factory method. Now we will add the class that will create instances of products from set 1. We will call this class concrete factory 1. And this has to inherit from the abstract factory so that it can inherit the interface for creating objects, that is, these methods. Create product A will create instance of product A1, and this will create instance of product B1. We will add the factory for the other set, that is concrete factory 2. Now this will return instance of product A from set 2. And create product B will return instance of product B2. Now we'll go to main, and we will not create the instances of products directly. Instead, we will use the factory. So I'll first create a pointer of abstract factory. And here we will instantiate one of the two concrete factories. First, let me instantiate concrete factory 1. And instead of using new, we will use the factory. In your application, whenever you need instance of any product, you will always create instances through the factory. We will remove the header files set1 and set2. We'll have to include the header file for the product B. This is it. Let's build. And the products are created from set 1. Let me change this code a bit. And we'll take this code and put it in this function. Now I will call use pattern and pass the factory pointer. And once we are done with the factory, we will delete it. Let's run. So we are able to use products from set 1. If we want to use products from set 2, then all we have to do is modify the place where we are creating the factory. So without modifying existing code, we are able to use products from the other set. This code that we have in this function will never change, although it can use products from a different set. So you see, abstract factory is quite similar to the factory method design pattern. Why? Because it allows us to create instances of classes without depending on their concrete types. So abstract factory design pattern also promotes loose coupling. And additionally, it also enforces a rule that the product instances that you get will be always from the same set or same family. Let's see how the classes are related through the class diagram. So here we are. We have two products, A and B, and we will have two flavors of these products. The flavors are represented by set 1 and set 2. So for product A, we have two flavors, product A1 and product A2, and for product B, we have product B1 and product B2. The client will be able to use products only from one set at a time. And how will the client get the instances? The client will use the factories. So factory 2 is responsible for creating instances of products that belong to set 2. And concrete factory 1 is responsible for creating instances of the product that belong to set 1. Just draw another line here that shows that it creates instance of this product A1. And the client will only deal with these classes. So you see, the client will not know about the concrete classes that it uses from different sets. I hope you have understood the structure and the design of the abstract factory design pattern. Now we will see a real-world example in which we will apply the abstract factory design pattern and see how it solves the problem.